Hey folks, welcome back to the shop. Frank here, working on the Cub Cadet tractor. It's an articulating 4x4 tractor with a dump bed. And my original plan for this episode or today was to start working on plumbing the spool valve to the hydraulic cylinders, making up some hoses and working on that. But I've kind of changed my direction here a little bit. I had planned to use the Power Beyond port on the steering valve to run it to the spool valve for the lift cylinders, and I bought a 2-spool valve just in case I needed the other spool for some other purpose. I only need 1 spool for the dump bed, but in order to do that, the Power Beyond port on the steering gear is pretty tight space now. When I originally installed it, I thought about putting a port on it, but I think it would have caused an interference with the linkage for the hydrostats, and in fact that's the situation. So I've decided to switch gears and use Power Beyond from the spool valve, but I didn't buy the right kind of, well, this spool valve could have a Power Beyond port if an adapter was available, spool valve converter, but it's not for this particular spool valve. So what I've done is ordered another spool valve, another hydraulic bidirectional control valve, directional control valve that has a Power Beyond port on it. And so for those that are not real familiar with hydraulics, and I'm still learning a lot about them, these valves have fluid in and fluid out, and those are the P and T, pump and tank ports, and then have AB for the 2 directions on the cylinder, up and down, or however you want to plumb it. This is 2 spools, so this could operate 2 different cylinders, 2 different functions. Now my cylinders are going to be plumbed in parallel, so I only need 1 valve, but I bought a double spool valve in case there's something else I want to operate with the other spool. And they call it spool because it's a little cylindrical shaft with lands and undercuts, and land is a fat section and an undercut is a narrow section on that, basically a polished rod, and it moves up and down, and as it does that it opens and closes ports that let fluid flow in different directions. The Power Beyond capability blocks off the tank return, so the Power Beyond has to provide return to the tank when there's no work being done. When you operate the spools, they separately send fluid back to the tank. So not all spool valves come with the Power Beyond port. If you are operating more than 1 valve assembly in a circuit, you need the Power Beyond port. And some of the valves come with a separate port designated as that, and some require a converter which screws into the tank, the T port, and it blocks off flow, unused flow from the input from the pump and sends it out the Power Beyond port. And the only time the fluid from that valve goes to the tank is when you operate either one of the spools. So you can buy, for a lot of the valves, there is a converter available to convert them to Power Beyond. So it's interesting way they build these valves. So there's a lot of functionality in them if you buy the right parts. Now, as it turns out, the converter adapter is not available for this particular valve. So this is a Chief valve from surpluscenter.com, and I bought a number of valves from them. They all work fine. This was inexpensive, and the valves run This was $120. Many of the valves are $300 or $400, and some as high as $500 or $600 from Surplus Center. Now, I have noticed that you can get valves much less expensively, apparently. I just looked today on eBay. So they have hydraulic valves that are new on eBay for about half that cost. I mean, as low as $50. So I almost bought a valve off eBay for $49 that came with an adapter. I wound up, I'd called Surplus Center, and I have to tell you, the people there are very knowledgeable. It's the second or third time I've called them with a hydraulics question, and the guys there know their stuff, I have to say. He explained some of this stuff to me that I didn't fully understand. I wound up buying the other valve from them. So it's on its way, be here in a week, less than a week, 5 or 6 days. So I have to say, if you're doing any of the stuff, any hydraulics stuff, my go-to place, and this is not sponsored or anything, they don't know who I am, is surpluscenter.com. So I buy my fittings, most of my adapters and fittings, other than the crimp-on fittings, which they don't really seem to carry, but any of the other fittings, JIC or O-ring, Boss, or pipe thread, whatever you need for your hydraulic system, they got them. They got a lot of other stuff too, motors and all kinds of stuff. So it's a pretty cool catalog of stuff. If you're tinkering around in your shop, it's a place to go to find a lot of different stuff. They've always been very helpful to me. That's all I can say. All right, I'm going to build this slanted support for the dump bed, changing gears from the hydraulics I was planning to work on, which I can't till I get that valve. I'm going to go ahead and build the slanted support for the dump bed, since I've redesigned the dump bed to be higher, the bottom of it to be higher in the back than the front. I'm going to build a little slanted support, just raise the back of the bed 3 inches. So I'm going to work on that, and hopefully we get time today or tomorrow, or in this episode anyway, cut out some pieces on the plasma table for the bracket that will mount the valve on the side of the dash tower. So that's one other thing I need to do. All right, let's get started. While I was editing the video, I realized I probably confused everybody with this talk about the Power Beyond port and steering gear and spool valve. So there's 2 different hydraulic valves on the tractor, and I'm just going to do a block diagram. And so my pump is the hydrostatic transmission. Right now I have it plumbed to the P port on the steering gear, so we'll do a steering wheel up here, and it comes back to the hydrostatic transmission, which is also the tank. So there is, a loop flows this way and this way. There is another valve, another connection on the steering gear, which is a Power Beyond. In other words, you can take fluid off of it and plug it into another valve, and then that would then be the equivalent of the pump, and then the tank would come back into this line here, so that would be the tank. And then you'd have A and B ports on there with your 2 spool valve controls, and this would give you the ability to provide high pressure fluid to this set pair of valves, pair of spools in this valve assembly, to operate the hydraulic cylinder. And then A and B would come off of here and go to the ports on a hydraulic cylinder, operate in both directions. this could go to another cylinder or something else. So this was the output, basically an auxiliary output from the steering gear, could power this valve. Well, the problem is I can't get to this now. It would be quite difficult. So changing gears, my plan then is to basically just invert this picture and send fluid to this pair of spool valves from the pump. It would have a return, and this would be the T port and this would be the P port. There's another port on here called N that you put an adapter in. Still has A and B for operating the cylinders. So this N becomes the power beyond port. So then it could go to my steering cylinder, so it would be the N, so that would be the P, and the T port, the output, would just join the return here. Now what happens is and this is the way I understand it, you screw an adapter into the N port, it blocks off this path, which is direct through, and directs it up to here, to the N port, to the power beyond port. So it's called power beyond because it provides power beyond this valve to some other valve or some other function. But when you operate the spools, it does spill the fluid to the tank port. So I think what I explained, in the video, I probably didn't explain well enough what my plan is to do. So that way I don't need to use that port at all. Both the spool valves and the steering gear work together. I mean, there may be because you're depending on the pressure here, you probably can't steer while you're operating the dump, which maybe is not a problem. So that may be one limitation. I'm not sure. But anyway, that's what I'm changing the hydraulic circuit design so that it comes from the pump. I can get to these connections easily. I can get to these two lines easily, much simpler and easier to manage the hoses to do that way. So that's what I'm trying to do, and that's why I need to get a new spool valve so I can get this port working. My current valve, there's no adapter to screw into the end port to give me power beyond. I hope that clarifies things a little bit. 28. All right, this is smaller than I'm going to use. I have some 1¼ angle I'm going to use. 28 inches. Cut 2 pieces. All right, so I need to cut 2 pieces of this, I guess 1.5 angle and 28 inches long. I'm going to try an experiment here. This may be anecdotal, but it'd be interesting to see. So I normally cut this with one of the sides against the back of the vise, so standing up. So I cut through one side and then flat across the bottom. Someone told me in the comments that it's faster to cut it this way. Cut through both sides at the same time. So we'll cut one this way and then we'll cut one the other way and see how it works out. All right, so I'm gonna turn it on and then I'll release the down feed. I'm just like let's see, 1/16 of an inch above the back of the metal for this one. Let me get my stopwatch out here. And turn it on, and then we'll hit release and start at the same time. All right, I hit stop. It was 13.3 seconds. My initial reaction is, yeah, that probably was faster. 28 inches here. Reset, come down, let's tighten the vise, turn it on, and I'll hit start and release at the same time. Okay, so that was 17, get that focus, can't focus on there, 17.5 seconds. So it's 4 seconds faster, 4 seconds out of 15, 13, I mean that's 25% faster. So I can see that as being valuable. I mean, if you're cutting a lot, especially bigger stuff, if it's proportionally faster on larger stuff, you could save 1/4 of your cut time. So, makes sense. So, see how these fit. All right, that's pretty good. So the results of the test showed that cutting it across diagonally is faster than cutting down one side and across the flat. So I think that's because the pressure on each tooth is higher for a given feed rate. You know, as the hydraulic cylinder bleeds down, that's the feed rate, and it applies some pressure on the teeth. So you only have a couple teeth engaged on the side, whereas across the flat you might have 20 teeth, 25 teeth engaged. So the pressure per tooth is a lot less across here than it is on a single side, going down a single side. course, cutting it diagonally does have teeth on both halves, and the length is a little bit greater. The engagement length, because you're at an angle, 45-degree angle roughly. So, yeah, I can see the pressure on the teeth is a lot higher when you cut it that way, because there's fewer teeth in contact with the metal. All right, I'm going to tack this up. For those of you that missed the episode last week, this is the new dump body design. I don't know for sure whether I'm going to have, channel on here or not. I decided that. I'll make that decision after I get the body itself built. But that's, I think, pretty close to what the final design is going to be. So it may sit a little bit forward, more like that. So, okay, let's move on to the next task. All right, here we are in Fusion, or Fusion 360 as it used to be called. This is a project that was developed a couple of years ago when I was working on the Bush Hog tractor project. These parts were modeled at that time. I'm going to reuse some of this stuff in this current project. I'm not going to use this middle part. I'm going to use the bottom one of these gussets, this small plate, and this larger plate. So in order to generate the G code to cut these out again, going into the profile, editing this profile. So the profile specifies the tool, the cut rate, and the geometry to cut. So I'm going to deselect the previous geometry. Oh, I see this has some holes in it. This plate has holes in it. All right, before we do that, let's go back into the design mode. Look at this again. The sketches, pull up sketch 2, go in here and see if we can delete these holes. All right, select the hole, hit delete. All right. Not sure why I had the holes in here. I looked at the existing tractor. I'll show you that in a few minutes, but it didn't have, and it also, this plate wasn't quite as long. Not sure why this is so long, but we'll leave it long because I'm not sure what we'll need. Won't make any difference. All right, so now I go back. Oh, let's extrude this. Press pull is the function here, but it also means extrude. All right. We'll extrude it 1/4 of an inch backwards. So then you'll see that it has some thickness there.
Okay. Let's take it into the manufacturer tab, and here I will pick this profile. Going down at the bottom of the directory tree here on the left, you'll see a profile. This is a cut profile. So we'll pick that and edit it. And here we'll be able to select which parts we want to actually generate G-code for. This profile specifies the plasma cutter, the cut speed, 40 inches per minute. The second tab selects the geometry. So I'm going to deselect the current geometry, select the part I want to cut, click on OK. Once I do that, the cut path is developed, and you'll see the little red and green dots here. That's entry and exit points. So this is the part. Now I'm going to simulate the cutting function. Can run the simulation here. I usually do that before I generate G-code just to make sure that the correct part is selected. Okay, exit simulation. Now I can post the G-code. Already, let's see, spool valve support bracket. Okay. Okay, let me pick the proper post processor, select that. All right. Pierce delay, 1/4 inch. I use 1.5 seconds. Hit enter. Okay, code's successfully posted here. We can go into fire control and pull that code in and cut it on the plasma table. We'll do that, and we'll pull the rest of these in. I'll go ahead off camera here, do the same thing for these other parts. 1, 2, 3 other parts, generate the G code, and then we'll pull them into fire control and cut them on the plasma table.
All right, I've launched Fire Control, which is the control program software for the CNC machine provided by the manufacturer, Langmeyer Systems. And I'm going to pull into here the bracket, which we just modified, remove those holes, extruded it, post-process it. So this is the cut program. So looking down here, I need a 20-inch by roughly 4-inch, and this is down this area here, 19.98 by 4.06. So a little over 20 inches by 4 or 5 inches in order to cut this piece out. Let me see if I have a piece of scrap that I can use. So I was looking for a piece of 1/4 inch scrap that was, 4 by 20, and I don't have any, and I don't even have a full sheet of 1/4 inch anywhere. So I have a steel delivery coming in. Let's see, today's Thursday. I have a steel delivery coming Monday. But I do have this channel, which is 1/4 inch web. So I'm going to try cutting it out of this. Never done this before, but seems like it should work if I have clearance for my head. Let's see. Well, I really don't. I do here. Okay. All right. So let's see if we can do this. All right, since, as I said, I don't have any other 1/4 inch sheet metal or plate steel that's adequate size, so this has 1/4 inch web approximately, piece of channel that's been sitting in the corner for 4 years. I have several more pieces, so I don't think I'll ever need this. So back here in fire control, I'm going to go ahead and tell the fire control where my torch is going to start, upper left hand corner, and just check my speed. Cut speed 40, pierce delay 1.5. That should all be correct for 1/4 inch. I'm going to add a little more water to the table. It evaporates so quickly. I've mentioned it before, this is green because it has plasma green 1050, an additive, 5% solution, keeps everything from rusting. If you don't use an additive to prevent rusting, this whole thing turns into a rusted mess. Okay, so my material is square to the table, everything's set. Go ahead and launch. That works perfect. Works perfectly. All right, so we go through the same process for this next part. All right, let's cut one more part here. One more part. I have to say that worked okay. I'm going to say this is not quite 1/4 inch. See what it is. That worked pretty well. This is a little bit less than 1/4. 0.210. No dross to speak of. I mean, just a little. Almost none. Nice clean cuts. It's got a little more on there, but all right. Clean this stuff up and got a couple bends to make. All right, this has little notches for my bend line. I need to make 2 more bends, and for some reason the notches did not come through on here, but it's 5 inches. And 7.5 inches. All right, so this is going away and this is turning in. Now let's go see if we can make some bends here. All right, so this is a standard central machinery, Harbor Freight 20-ton press. I have a winch on here which raises and lowers the table, and I've added an air over hydraulic jack to it, make it a little easier to operate. And this is a swag off-road heavy duty finger brake, and there's a couple different videos on the channel. One building this DIY finger brake, so they sell kits. So that's one of them. That's one video. Another video for adding the winch. I don't think I did a video for the air over hydraulic jack, since it's not that much involved here. I do have just a old mill vise down here to raise up the brake on the table. All right, I'm going to use it to bend these plates. My dogs are going crazy outside because they're delivering materials. One of the couple videos ago, I showed the addition. That's I call it a Moffat. It's the kind of a 3-wheeled forklift that goes on the back of a delivery truck. They take it off the truck and deliver stuff with it. Runs sideways. I'm kind of back in the woods, so it's difficult for the big trucks to get back here. They have to back all the way. So I've got the plates to bend here. And I got my little Wixie gauge here. To stick my head in. Well, that's actually a little overbent. That worked better. All right, I think that'll work fine. A little sketchy setup here. There's only one dimension that matters, and that's the distance between these two holes. I set my DRO to 0, 0, and then I'll just move 2.5 inches this way.
Are you sure about that?
Got the vise locked down pretty tight. This is not the most rigid setup. All right. Reset 2.5 inches. There we go. Well, that didn't work. Well, that was absolutely dumb of me. This was 3.5, so I came in 1/2 inch from each direction. That was really dumb. All right, try this again. I'm going to do a hole here. And let's see where 2.5 inches falls. I want it to fall down here past this hole. So that's why they say measure twice, cut once. That'll still work. What you doing, Mr. Butchie? The air compressor's running, you don't like that? What's going on, Mr. Butchie? He said, Daddy, I don't like the air compressor. The only problem is they've been raising so much trouble outside with the contractors here that I brought them in. Where's Brew Brew? Where'd Brew Brew go? Oh. It's okay. Air compressor's finished. Alright, I've got the bracket attached here. I'll kind of give you an idea of what the valve alignment's going to be. Let me put the camera back in the tripod here. My good Butchie, my good Butchie. Okay. Yeah. It's okay. I know you don't like the compressor, but it's all stopped. It's all okay now. It's okay. It's okay. It's okay. Yeah, my good boy. My good boy. Yeah, it's okay. It's okay. It's funny because thunder, doesn't bother him, but it really bothers Brew Brew. But the air compressor doesn't bother Brew Brew as much as it does Butchie. So, I don't know why, but it's too loud. Okay. Good boy. Good boy. Good boy. And it's kind of tight quarters here. You have to back up. Go this way. Go that way. There you go. They're so silly. All right. This is a plate. This is a plate. This plate's going to get welded at a 90-degree angle. This plate will be bolted to it. The valve will be fastened to this plate, mounted, something like that. Depending on, how I have to run my lines. Sometimes you have to make allowance for lines coming out of these two ports, though this port and this port are the same. So this is the end port, which would normally be power beyond if you had the proper adapter for it, but they're telling me that they don't have it. So here's P for the pump, T for the tank, and like I said earlier, I'm not going to be able to use this valve, but when I get the replacement valve, we'll decide exactly where it's going to go on here, and I'll cut the excess off of this plate. I don't know why now, I'm thinking back to the other installation. I don't know why this is so long. I don't remember now what I did. I do know I used this file. It seemed long when I was cutting it, but I'm assuming that in the previous one I cut it off up here someplace, rounded the corners over. So we'll do the same with this. So here's the installation on the Bush Hog tractor. And it looks like, yeah, the bottom plate is cut off flush with the valve support plate. And the gusset is in the corner there in the back, you can see. So I clearly made a change that's was not reflected in that Fusion file. So, okay, we'll just cut the plate we're working on off at that point. So if you haven't seen this tractor, this is a Cub Cadet with a rear PTO and a 3-point hitch, hydraulic 3-point hitch, and that's what the spool valves are for. It is a gear drive tractor, so it doesn't have hydrostatic transmissions, it's got a gear drive. The only tractors that came with the rear PTO, and they're pretty unusual, were the gear drive tractors. So you can't do that with a hydrostatic transmission. It does have a hydraulic pump, which is PTO driven off the front of the tractor, and a counterweight on the front to account for the bush hog. We built a 4-foot bush hog for this tractor. So there's several videos, a video series on the channel showing that project. So the hydraulics on this tractor are a lot different from the hydraulics that we're working on now. Since this has a PTO driven pump, it's putting out 2,000 psi, full hydraulic pressure, in order to operate the hydraulics for the rear lift here. And it was necessary to put the pump on this tractor since it didn't have the hydrostatic transmission that would have the auxiliary output ports. There is a little gusset stiffener that goes in this corner here. You saw me cut that out. We'll weld that in. We'd like to get the exact location settled first. So that's basically what we're doing here. All right, folks, that's it for this week. We'll come back next week, continuing to work on the hydraulics, get that set up and get the lift frame actually operating, and then we'll shift our focus to the bed itself and start working on that. Meanwhile, I've got a steel delivery coming Monday, so we'll see you next week. Thanks for watching.